Hi, so now I finished my project. It's a personal power plant. It uses this solar panel and this gear, which can be turned um, by this handle, an improvised chopstick, um, which turns a motor, and that generates electricity to be stored in this battery, 7.2 volt NIMH battery. So the first part of this project was to make the motor work, and so I had to make this gear system right here. It's turned by this chopstick or your hand. When the box closes, it's easier. This large gear turns a smaller gear, which is directly epoxied onto the very motor. And so at first this large gear was giving me problems. It was very stiff, and after I turned it for a while, the binding post, which was the axle, completely broke, and it blew up washers all over the place. So now I'm using this ball bearing, which I don't know if you can see, is this black thing. And the ball bearing makes it a lot easier and smoother to turn, which makes the entire process of charging the battery so much easier and makes it faster to get it done. The motor, the way this works is that when the shaft turns, it generates electricity inside two electromagnetic coils, which produces an alternating current. An alternating current is shaped like a sine wave, and so since it's occasionally negative and positive, it makes the current flow in both directions, which is really bad for charging a battery, since it makes the battery randomly charge and then discharge. So what I had to do is I made two rectifiers, one for each coil of the magnet. And a rectifier is just a series of diodes arranged in a sort of ring or circle shape. So from these leads that came out of that come from the motor, I just here attach them into this 5-pin male header, which then attached to these rectifiers, and I have one for each coil of the motor. And the diodes there change the sine wave to omit the negative oscillation and make the entire thing positive, which is only going to charge the battery instead of discharging the battery. On the bottom of this circuit board, I have two open wire rails. These two open wires, and from there they lead onto these two terminals. One of them also connects to the solar panel, and the other connects to an output terminal and also the cables that lead to the battery for charging. And then one of the cooler parts was this sort of visual multimeter that I added to sort of gauge how much was going into the battery, how much is already in the battery. So here I have 3 Zener diodes, and I place them against the flow of the current so that when the momentary switch, which is connected on one end to the open rail, when I push the button, it closes the circuit and sends the current through these 3 diodes, which are placed backwards. And Zener diodes are special because they can safely allow current to flow through. They can safely allow current to flow through when it's at a certain flow in the reverse direction when it's at a certain voltage. And each of these Zener diodes have a different sort of breakdown point or avalanche point. So the bottom one is 3.2 volts. The bottom, it's 3 volts, 5 volts, and then 7 volts. And then followed by that are 100 ohm, 150 ohm, and just a plain jumper, these resistors and a jumper. And after that, it passes through to these 3 LEDs. So these 3 are all sort of run in a parallel sort of circuit, so that the voltage is conserved at each point. So, which is really important, because if it was a series circuit, then by the time it got to the Zener diode with the highest breakdown point, by then this voltage would have already sort of gone down by a lot, and it wouldn't provide the same accuracy of a reading. So whenever I push the button it will show me, based on how high the voltage is, whether or not it's able to go through past the Zener diodes and the resistors and light up the LED. It will show me how much voltage there is. So if I push the button and turn this, you can see that, let me close this. You can see that the green and the yellow LED both light up. So there's at least 3 volts and at least 5 volts inside the, at least 3 volts and at least 5 volts being generated. And also, because whenever the battery is plugged in and I'm not exactly using the solar panel or the crank, it's going to be discharging. So whenever I plug in the battery and don't touch anything except for the switch, and I just push the button, it'll also tell me how much I have inside the battery. So again, it's at right above 5 volts, and since it's so dim, it's probably just over about 5.2 volts maybe. And also, I've tested the solar panel produces about the same amount. Okay. Go. So right now I'm outside, and I can use the solar. I can show you how the solar panel works. So right now it's in direct sunlight, and when I push, and there's no battery attached. When I push the button, it's pretty brown. I don't know if you can see it, but the green and the yellow lights both come on right now. So that means there's at least 5 volts about going into, if there was a battery, it would be going into the battery. If I cover this a little bit, it gets dimmer, and if I cover this enough, only the green light will show up. And my hand's not that big.